If you are working in Grasshopper, you may have wondered, how does it handle multiple items at once? This is where the real power and flexibility of Grasshopper lies. In this video, we'll try to understand just that with an experiment. First of all, notice how Grasshopper uses words to communicate the data structure. A single line means a single item, a double line means a list, and a dotted line means a list of lists, or more accurately, a tree. Let's understand this with a simple example, the line AB component. This component takes 2 points as inputs and produces a line between the 2 points. But remember, this logic applies to almost every component in Grasshopper. Let's examine a few cases of its usage. First, if we connect a single point to both A and B, it simply draws a line between point A and point B. That's straightforward. But now, if one input is a single point and other input is a list of points, the single point acts with every item of the list and produces corresponding lines as a list. What if both inputs are lists of points? Grasshopper matches them item by item. The first point of list A connects with the first point of list B to produce the first line on the output list, and the second point connects with the second points to produce the second line, and so on and so on. Now, let's see what happens with trees. If one input is a single point and other input is a tree of points, then the single point acts with every list of the tree and produces corresponding lists of lines, ultimately producing a tree of lines of the same data structure as the input tree. If we change the single point with a list of points, then similarly, the list acts with every list of the tree and produces corresponding lists of lines, which is also a tree. If both inputs are trees of same structure, the corresponding lists act to produce corresponding output of the same data structure. Here is another example where both inputs are trees. Notice that the first tree is composed of lists of single items. Nonetheless, it acts as the same as before. Corresponding inputs connect together to form corresponding outputs. Grasshopper data structures are very intuitive. Let's wrap up this video by a practical example. Here is a point component that takes the coordinates as inputs and produces a point. If we put a list of number on one of the inputs, then it produces a list of points. Now, let's make lines from the list of points using the line SDL component. Here, a single number represents the length of the lines, so all the lines are of the same length. If we want to have control over the length of each lines, then we have to provide a list of numbers. Note that when matching inputs, the length of the list should be equal.